Good morning. It's time for another Learning Rest stream. So, I was taking a look at where we're at today, and it looks like we're at Chapter 11, Adding Custom Failure Messages. So this is the book section we're at, and I'm gonna listen to. I'm gonna turn this into dark mode. And there you go. A little bit easier on my eyes, at least. All right, so let's just hop into it. Adding custom failure messages. You can also add a custom message to be printed with the failure message as optional arguments to assert equal, and assert not equal macros. Any argument specified after the one required argument to assert, or the two required arguments to assert equal and assert not equal, are passed along to the format macro discussed in Chapter 8 in concatenation with the plus operator or the format macro section. So you can pass a format string that contains empty quote placeholders and values to go in those placeholders. Custom messages are used to document what an assertion means. When a test fails, you'll have a better idea of what the problem is with the code. Miguel, good morning. For example, let's say we have a function that greets people by name, and we want to test that the name we pass into the function appears in the output. So let's actually just, before I investigate that too much, we have a public mod shapes. Well, I'm going to create public mod adders. Let's just create another pub mod greeters. Okay, so then we'll have a public function, and it's gonna greet. This is gonna take in a reference. Well, it's gonna take in a name, which is a reference to a string. It's not gonna return. Well, yeah, it is gonna return probably a new string, because otherwise we'd have to do. Well, actually, no, we could do a reference to a string. Although if we're creating a string here, it's probably better if we just have a full string. That way, it's on the heap. We can give ownership back to the calling function and let it deal with the memory. Okay, so now it's just yelling at us that we're not returning the correct thing. So we're going to take in the name, and we're going to return the actual whatever, the string. Yeah, I'm tired. So we're probably going to use format here. So we could just return format, and it's going to be hello, your hello, good morning, or just good morning, and then it's going to be the name. So of course, in this module, we want to do the testing right here. So this will be a test, and it'll be a function. It greet should use name. Okay, so in here we're going to call let result equals greet, and we're going to pass it in Brooks. And then what should we do? We want to now assert equal. So assert equal that results is the same as good morning, Brooks. And then we're going to have this entire statement in case this doesn't work. So what is that going to look like? I think it's, I mean, either we could use a format. I think they say it was pasta format, so I could just put whatever I want in here, or do I actually use format to throw into here? I think it doesn't matter either way, because I could just say the name was not unhappy. Okay, so let's try testing that. I'm in the wrong directory. Okay, so I want to be in chapter 11, adder, cargo test. Greet should use name. Okay, so then if we change this to, like, let's say we used your name. Oh, can I not grab your name easily? Oh, of course not. Oh, there it is. You chatted, so we're gonna pass in your name, but expect mine to come in. So we should get an error now saying, hey, I did this wrong. Failed. Okay, so failures, thread, greeters, greet should use name, panicked at assertion failed. And then here it is. Good morning, Brooks. The name was not correct. So that's pretty perfect. And so we'll go ahead and put this back here. And therefore you'll now be forever in the test, Miguel. You're we're greeting you in a test. Okay, so back to the text here. So let's see. They did the exact same thing. Assert. I don't see them using. Yeah, I'm not seeing them using anything crazy. Like, I'm not seeing them use this second thing, so it must be down here. The requirements for this program haven't been agreed upon yet, and we're pretty sure the hello text at the beginning of the greeting will change. We decide we don't want to have to update the test when the requirements change, so instead of checking for exact equality to the value returned from the greeting function, we'll just assert that the output contains the text of the input parameter. Let's introduce a bug into this code by changing greeting to not include name. Oh, okay, I see. They're doing result contains Carol. Let's introduce a bug into this code by changing greeting to not include name to see what this test failure looks like. So, yeah, so we saw the error, but I do agree that probably contains would be best, because then we could say something like hello or something like that. So we really want to do assert, and then it's going to be result.contains, and in this case, that. Let's try running this and make sure it works. Yep, so that actually is probably a better way, because then we could like change around the other hello part of it. Yep, so we saw the error on our system. This result just indicates that the assertion failed and which line the assertion is on. A more useful failure message in this case would print the value we got from the greeting function. Let's change the test function, giving it a custom failure message made from a format string with a placeholder filled in with the actual value we got from the greeting function. Oh, wait. Right, because If we did the assert equal, then we would get the left and right, and so we would get that information. But this time we do not. So in this case is the name was not correct, unhappy face. We got this instead. And we can throw this inside of quotes. And this we want to put in a format here. And then we'll put in here the result. So that way, if we were to misspell your name, for example, then we'll get our nice formatted string. Really? Oh yeah, you know what? I have to go one more character instead of one less because of course it contained those characters. Okay, so the name was not correct. We got good morning. Okay, so that is correct. So let's go ahead and make it work again. We place the should panic attribute after the test attribute and before the test function applies to. Let's look at the result when this test passes. Wait, what? Why are we doing should panic? Oh, I accidentally paged down, I think. Okay, so we did a custom error message, now we run. We can see the value that we actually got. Okay, so I just went one page down. In addition, so checking for panics with should panic. In addition, for checking that our code returns the correct values we expect, it's also important to check that our code handles error conditions as we expect. For example, consider the guest type that we created in chapter 9, listing 99. Other code that uses guest depends on the guarantee that guest instances will contain only values between 1 and 100. We can write a test that ensures that attempting to create a guest instance with a value outside that range panics. We do this by adding another attribute, should panic, to our test function. This attribute makes a test pass if the code inside the function panics. The test will fail if the code inside the function doesn't panic. Listing 11.8 shows a test that checks that the error conditions of guess new happen when we expect them to. Okay, so we have a structure guess. It's a U32 key value. We implement into guess, like, hey, we want to get into here. And then we have this should panic greater than 100. Guess new. So the interesting thing here is that it doesn't look, oh, it is. If it's less than 1 or greater than 100, we will panic. Okay, so I'm okay with let's add this in, and maybe what we'll do is put in something into our one of these tests, like a shape. We have a U32 here, but maybe we want to say something like we want to implement new ones of them. So here's a implement rectangle function can hold. We can do a pub function new, and this will of course bring in self. We don't need like an other or anything. And this is going to return a rectangle. And so we're going to first, I guess it's not just going to take in self. We're going to take in length, which is going to be a U32, height 2. And then maybe what we want to do is say, okay, so we're bringing these in. If length is less than like 5, and length, I think it's or we could just do nothing can be less than 5. So, and height is less than 5. Then arbitrary panic for no reason. Panic, you are not allowed to create such small rectangle. Okay, so that's the panic. Now if we successfully get past this if statement, then we can return the rectangle. So then we just return rectangle, and it's going to be length of, can I do this? Is it length, width? I can't remember if it allows me to do this syntax. Can I find value width in this scope? Oh, length, height. I mean, it's not yelling at me, so, or maybe it is. It's width. So you both should be width. Okay, so it's not yelling at me, so I think that I actually can do this because it's going to basically say, okay, well, this is the equivalent of length colon length. And so then we have our test for the rectangle struct, and we assert rect small can hold. We can do one more. A test equal, it is equal. And then we can also do function, it is not allowed to be small. It is not small. And then here's where I think we have the should panic. Let's see if I got that right. It is, yep, it's just, oh, so these have separate, so we can't put them together like this. So we just have another should panic that. So then we're going to call in let rect equals rectangle new, and we're going to pass it like 1 and 2, and that should panic for us. So let's try this. Expected 3 parameters. Really? In our implementation, we length and width. I don't think I can leave off self, right? Oh, it needs to be public. Definitely needs to be public also. So public new here. Wait, this is public. This is pub. Okay, those things are all public. Oh, it's this rect is not used. Yeah, I don't care about that. Warn unused variables on by default. I wonder if I can get away with this by just not assigning it to a variable and just saying, hey, like that should panic. Okay, that works. I noticed in a new version of Rust, they're adding like a must use. Is it a trait or like one of these? So basically it's saying like, okay, I cannot just do this. I would have to assign it to a variable and then use that variable. I can't just call it and let it like die like this. But like this seems to work. We place the should panic attribute, or attributes after the test attribute and before the test function it applies to. Let's look at the result when this test passes. Yep, so complete normal. Looks good. Now let's introduce a bug in our code by removing the condition that the new function will panic if the value is greater than 100. So when we run the test, it just failed because it didn't panic. And we could do that ourselves by simply adding in a 1 to each of these, so that it will be bigger and will actually do the thing. It is not small, failed, test result failed. And of course, I believe, oh, we can't, there is no way to put in a message in this case. We don't get a very helpful message in this case, but when we look at the test function, we see that it's annotated with should panic. The failure we got means that the code in the test function did not cause a panic. Tests that use should panic can be imprecise because they only indicate that the code has caused some panic. A should panic test would pass even if the test panics for a different reason than the one we were expecting to happen. To make should panic tests more precise, we can add an optional expected parameter to the should panic attribute. The test harness will make sure that the failure message contains the provided text. For example, consider the modified code for guess in listing 11.9, where the new function panics with different messages depending on whether the value is too small or too large. So in the should panic attribute, we have parentheses and then expected equals. Okay, so should panic parentheses expected equals, and then we can say anything that we want here, like the rectangle you are creating is too small. Make it at least 5 by 5. Make it at least 5 by 5. So okay, so it is not small. This should fail. So even if we set this back to 1 and 2, it should still fail because it's not that exact message. Okay, so note, panic did not include expected string. So perfect. So then in our programming, we can now take this, copy that, and change it out to this. And everything should run again. Perfect. This task will pass because the value we put into should panic attributes expected parameters as substring of the message that the guess new function panics with. We could have specified the entire panic message that we expect, which in this case would be guess value must be less than or equal to 100, got 200. What you chose to specify in the expected parameter for should panic depends on how much of the panic message is unique or dynamic and how precise you want your test to be. In this case, a substring of the panic message is enough to ensure that the code in the test function executes if the else if value greater than 100. I mean, oh, so what's interesting is that expected is just a substring. We don't have to like say substring or anything. It just will be. To see what happens when a should panic test with an expected message fails, let's again introduce a bug into our code by swapping the bodies of the if value is less than 1 and the else if value is greater than 100 blocks. This time when we read the should panic, the test, it will fail. Note, panic did not include expected string. Perfect. The failure message indicates that this test did indeed panic as we expected, but the panic message did not include the expected string. Guess value must be less than or greater or equal to 100. The panic message that we did get in this case was, guess value must be greater than or equal to 1, got 200. Now we can start figuring out where our bug is. Now that you know several ways to write tests, let's look at what is happening when we run our tests and explore the different options that we can use with Cargo Test. Let's take a look at where we're at here. That was just writing tests. Now we're going to go into running test section. 11.2. Controlling how tests are run. Just as Cargo Run compiles your code and then runs the resulting binary, Cargo Test compiles your code in test mode and runs the resulting test binary. You can specify command line options to change the default behavior of Cargo Test. Interesting. For example, the default behavior of the binary produced by Cargo Test is to run all the tests in parallel and capture output generated during test runs, preventing the output from being displayed and making it easier to read the output related to the test results. Also, potentially making it a little bit faster if it's able to use multi-cores. If it's only multi-threaded, I'm not actually sure that's going to be any faster. Some command line options go to Cargo Test, and some go to the resulting test binary. To separate these two types of arguments, you list the arguments that go to Cargo Test, followed by the separator --, and then the ones that go to test binary. Running Cargo Test -- help displays the options you can use with Cargo Test, and running Cargo Test -- help displays the options you can use after the separator --. Okay, that's a bit hard to read, and I'm actually not exactly sure what they're trying to say here. I guess like I can pass it into my program. Running tests in parallel or consecutively. When you run multiple tests, by default they run in parallel using threads. This means the test will finish running faster so you can get feedback quicker on whether or not your code is working. Because the tests are running at the same time, making sure your tests don't depend on each other or on any shared state, including a shared environment, such as the current working directory or environment variables. For example, say each of your tests run some code that creates a file on disk named testoutput.txt and writes some data to that file. Then each test reads the data in that file and asserts that the file contains a particular value, which is different in each test. Because the tests run at the same time, one test might overwrite the file between another test writes and reads the file. The second test will then fail, not because the code is incorrect, but because the tests have interfered with each other while running in parallel. One solution is to make sure each test writes to a different file. Another solution is to run the tests one at a time. If you don't want to run the tests in parallel, or if you want to more fine-grained control over the number of threads used, you can use the test threads flag and the number of threads you want to use to test a binary. Take a look at the following example. So Cargo Test, then we do this -- and then test threads 1. So this is what we're passing into the binary that was created that runs the tests, and then that only runs in one thread. let's try it. So we're gonna do cargo test. So we do the dash dash space, then dash dash test threads equals 1. Okay, so unoptimized, 0.0 seconds, and then it worked. If I don't include that, how long does it take? About the same amount of time. I need something bigger to actually do a real test, because it's my understanding that when we difference between threads and cores is that with a thread, it's basically saying, okay, we have these two things, or maybe more than that, and the CPU will say like, okay, I'm gonna do a little bit of this, 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 a little bit of this. That actually slows it a little bit down because like there's a slight context change hit that happens when it goes back and forth. But it is able to now like do multiple things at the same time. So for example, if you're in a web server where you want people to actually see progress being happening for them, then threads is a really good thing. But if you can, multiple cores is even better. Okay, so we did this. Showing functions output. By default, if a test passes, Rust test library captures anything printed to standard output. For example, if we call print line in a test and the test passes, we won't see the print line output in the terminal. We'll only see that the line has we'll only see the line that indicates the test passed. If a test fails, we'll see whatever was printed as standard output with the rest of the failure message. So custom success messages now. That's gonna be cool. As an example, listing 1110 has a silly function that prints the value of its parameter and returns 10, as well as a test that passes and a test that fails. Okay. When we run these tests with cargo test, we'll see the following output. So we get the OK, we get the standard fail message. Note that nowhere in this output do we see I got the value 4, which is what is printed when the test that passes runs. So they're talking about this print line. Note that, let's see. The output from the test that failed, I got the values 8, appears in a section of the test summary output, which also shows the cause of the test failure. If we want to see printed values for passing tests as well, we can disable the output capture behavior by using the -- no capture flag. When we run the test in listing 1110 again with the -- no capture flag, we see the following output. So I got the value. So that's sort of like allowing console logs in JavaScript or prints in other languages. Note that the output for the test and the test results are interleaved. The result is that the tests are running in parallel, as we talked about in a previous section. Try using the test threads 1 option and a no capture flag and see what the output looks like. I'm okay with like just sort of like leaving this for right now. Running a subset of tests by name. Sometimes running a full test suite can take a long time. If you're working on code in a particular area, you might want to run only the tests pertaining to that code. You can choose which tests to run by passing cargo test, the name or names of the test that we want to run as an argument. To demonstrate how to run a subset of tests, we'll create 3 tests for add2 functions as shown in listing 1111 and choose which ones to run. We actually already did this in the last video yesterday. If we run the test without passing any arguments, we'll run all of them. Otherwise, you can pass the name of any test to cargo test and only run that test. Only the test with the name 100 ran. The other two tests didn't match that name. The test output lets us know that we have more tests than what this command ran by displaying 2 filtered out at the end of the summary line. We cannot specify the names of multiple tests in this way. Only the first value given each cargo test will be used. There is a way to run multiple tests. Filtering to run multiple tests. We can specify part of a test name, and any test whose name matches that value will be run. For example, because 2 of our test names contain add, we can run those 2 by running cargo test add. Oh, interesting. So it's cargo test add because 2 of our test names contain add. So it's like whatever tests include these things. So if we have a couple that are it, or we could run the full test suite first. So we can take a look. We have add, greet, it is equal, it is not small. So if I do cargo test it, should only get those 2. Okay, so that's actually an interesting way to filter. This command ran all the tests with add and name and filtered out the test named 100. Also note that the module in which tests appear becomes part of the test name. So we can run all the tests in a module by filtering out the module's name. Oh, interesting. So we could say we want shapes. So and then it runs all of those. That's actually nice too. I could see potential namespace problems if we have modules that like include each other's names in them. Ignoring some tests unless specifically requested. Sometimes a few specific tests can be very time consuming to execute. So you might want to exclude them during most of our runs of cargo test. Rather than listing as arguments all tests you do want to run, you can instead annotate the time-consuming tests using the ignore attribute to exclude them as shown here. So we can just ignore them using that. After test, we run the ignore line, the test we want to exclude. Now when we run our test, it works, runs, but expensive test doesn't. The expensive test function is listed as ignored. If we want to run only the ignored tests, we can use cargo test -- ignored. By controlling which tests run, you can make sure your cargo test results will be fast. When you're at a point where it makes sense to check the results of the ignored test and you have time to wait for the results, you can run the cargo test -- ignore instead. Right. Flying through these chapters. Test organization. As mentioned at the start of the chapter, testing is a complex discipline, and different people use different terminology and organization. The Rust community thinks about tests in terms of 2 main categories: unit tests and integration tests. Unit tests are small and more focused, testing one module in isolation at a time, and can test private interfaces. Integration tests are entirely external to your library and use your code in the same way any other external code would, using only the public interface and potentially exercising multiple modules per test. Writing both kinds of tests is important to ensure that the pieces of your library are doing what you expect them to, separately and together. Unit tests. The purpose of unit tests is to test each unit of code in isolation from the rest of the code to quickly pinpoint where the code is and isn't working as expected. You'll put unit tests in the source directory and each file with the code that they're testing. The convention is to create a module named tests in each file to contain the test functions and to annotate the module with config test. So apparently, what I did here is not standard, which is I have the public mod shakes and then I had the tests for these shapes in the module. That way they're as close as possible right here, which also means that when I code fold, all the tests for those are gone too. The config test annotation on the test module tells Rust to compile and run the test code only when you run cargo test, not when you run cargo build. This saves compile time when you only want to build the library and save space in the resulting compiled artifact because the tests are not included. You'll see that because integration tests go in a different directory, they don't need the config test annotation. However, because unit tests go in the same files as the code, you'll use config test to specify that they should not be included in the compiled result. So that's the reason. So that above the having them here. So having like the config test so that it doesn't get compiled into the resulting binary. I think that's definitely the reason why we don't want to include that. So this is the best way to do it because of that itself. Okay. Recall that when we generated the new adder project in the first section of this chapter, Cargo generated this code for us. Yep. This code is the automatically generated test module. The attribute config stands for configuration and tells Rust that the following items should only be included given a certain configuration option. In this case, the configuration option is test, which is provided by Rust for compiling and running tests. By using the config attribute, Cargo compiles our test code only if we actively run the tests with cargo test. This includes any helper functions that might be within this module, in addition to the functions annotated test. Testing private functions. There's debate within the testing community about whether or not private functions should be tested directly, and other languages make it difficult or impossible to test private functions. Regardless of which testing ideology you adhere to, Rust privacy rules do allow you to test private functions. Consider the code in listing 11.12 with the private function internal adder. So we have internal adder here, use super function internal. So that does seem to work. Note that the internal adder function is not marked as pub, but because tests are just Rust code and the test module is just another module, you can import and call internal adder in a test just fine. If you don't think private functions should be tested, there's nothing in Rust that will compel you to do so. Integration tests. In Rust, integration tests are entirely external to your library. They use your library in the same way any other code would, which means they can only call functions that are part of your library's public API. Their purpose is to test whether many parts of your library work together correctly. Units of code that work correctly on their own could have problems when integrated, so test coverage of the integrated code is important as well. To create integration tests, you first need a tests directory. We create a test directory at the top level of our project directory, next to source. Cargo knows where to look for integration test files in this directory. We can then make as many test files as we want to in this directory, and Cargo will compile each of the files as an individual crate. Let's create an integration test with code in listing 11.12 still in the source lib.rs file, making a test directory, create a new file named test integration tests rs, and enter the code in listing 11.3. So I don't think I need to name it integration tests. It's just the name of the folder is important. If we take a look here, we're in, I think it's just, they said it was in source, right? Next to source. So we want to make dir tests, and then we can touch tests, and then, for example, one of our things is the rectangle. Rectangle. Now they're calling them integration tests. I can call this one rectangle test. test.rs. So that will now be available to us. Sort of grab in here. Let's see what we'd put in. So extern create the adder test. It adds 2. Insert adder, add 2. Okay, so inside of here, we'll do our extern create. Now we get adder from the cargo.toml. We say name adder. So that's how we get that. Adder. And then we want to probably use adder. So let's do shapes. If we take a look at our library, we have public mod shapes, which has our rectangle. So we can do the new one. So then we just have the same annotation for test, and then we can do that. And so we'll have function. Oh, I think we also want the panic too. Should panic. What was it? Expect. Or is it just this thing where we just put in expect equals blah blah blah. So of course that should fail. So cannot rectangle cannot be too small. Rectangle not be So then we want to do shapes, rectangle, new, so length and width, and I'll just do 1, 2, 4, and then we will that should just work for us. So if we run this, rectangle cannot be too small should now run. So cargo test. Okay, so it is finding it. Expected. Oh, did I not put a semicolon on here? I didn't. So it actually tried to return it. Okay, so we got a few errors here and warnings. So argument must be in the form of expected equals error message. So expected. This is expect. Try it again. All right, so rectangle is not small. So this is the first series of tests. Then running. So then it runs our integration test, running one test. Test rectangle cannot be too small. Failed. Panicked at the rectangle you're creating is too small. Make it at least 5 by 5. Panic did not include expected string. Blah blah blah. So if we do this. This should now make it work because even though it's not the full string, it's a substring of it. Yep, so everything works then. We've added extern create adder at the top of the code, which we didn't need in the unit tests. The reason is that each test in the test directory is a separate crate, so we need to import our library into each of them. We don't need to annotate any code in test integration tests with config test. Cargo treats the test directory specially and compiles files in this directory only when we run cargo test. Run cargo tests now. So we did that. The three sections of output include the unit test, the integration test, and the doc tests. The first section for unit tests is the same as we've been seeing. One line for each unit test, one named internal that we added in listing 1112, and then a summary line for the unit tests. The integration test section starts with the line running target debug deps, integration test, blah blah blah. The hash at the end of your output will be different. Next, there is a line for each test function in that integration test and a summary line for the results of the integration test just before the doc test adder section starts. Similarly to how adding more unit test functions add more result lines to the unit test section, adding more test functions to the integration test file adds more result lines to this integration test file section. Each integration test file has its own section. So if we add more files in that test directory, we'll be adding more integration test sections too. We can still run a particular integration test function by specifying the test function's name as an argument to cargo test. To run all the tests in a particular integration test file, use the -- test argument instead of the cargo test, followed by the name of the file. That's actually interesting. This command runs only so submodules in the integration tests. So this will move us to integration tests for binary crates, and then we'll be done because it's 7:50. We might be able to finish. As you add more integration tests, you might want to make more than one file in the test directory to help organize them. For example, you can group the test functions by the functionality they're testing. As mentioned earlier, each file in the test directory is compiled as its own separate crate. Treating each integration test file as its own crate is useful to create behavior scopes that are separate scopes that are more like the way end users will be using their crate. However, this means files in the test directory don't share the same behavior as files in source do, as you learned in Chapter 7 regarding how to separate code into modules and files. The different behavior files in a test directory is most noticeable when you have a set of helper functions that would be useful in multiple integration test files, and you try to follow the steps in the moving modules to other files section of Chapter 7 to extract them into a common module. For example, if we create test common rs and place a function named setup in it, we can add some code to setup that we want to call from multiple test functions in multiple test files. When we run the test again, we'll see a new section of the test output for the common rs file, even though this file doesn't contain any test functions, nor do we call the setup function anywhere. So it actually does it have to be named common rs? So if we name if in here we create a common rs, so if we do just a function, because this is pub function setup. And what are we doing here? We're just like setting up specific code, so we just do something silly like print line. Hi there. It's not really doing anything for us. But what it's saying is that it won't run the tests. Yeah, so it doesn't run the tests. So it doesn't matter what the file is called. Setup just runs probably before the context is done. So now multiple test files can pull in this file and then run it. When we run the test again, we see a new section, a test output for common rs file, even though the file doesn't contain any test functions, nor did we call the setup function from anywhere. Isn't the output captured? Well, so it would be, we'd have to have that like -- capture output flag set. Having common appear in the test results with running 0 test displayed for it is not what we wanted. We just wanted to share some code with the other integration test files. To avoid having common appear in the test output, instead of creating test common rs, we'll create test common mod rs. In the Rules of Module File System section of Chapter 7, we use the naming convention's module name mod rs for files and modules that have submodules. We don't have submodules for common here, but naming the file this way tells Rust not to treat the common module as an integration test file. When we move the setup function code into tests common, the folder common mod rs, and delete test common rs file, the section in the test output will no longer appear. Files and subdirectories of the test directory don't get compiled as separate crates or have sections in the test output. So files in subdirectories of the test directory do not get compiled as separate crates. So I think that's the important thing, is it just needs to be in a subdirectory. After we've created test common mod rs, we can use it from any of the integration test files as a module. Here's an example of calling the setup function from the it adds two tests here. So extern create adder, mod common, and then we can call common setup. Note that the mod common declaration is the same as the module declarations we demonstrated in listing 7.4. Then in the test function, we can call the common setup function. Integration test for binary crates. If our project is a binary crate that only contains a source main.rs file and doesn't have a source lib.rs file, we can't create integration tests in a test directory and use extern crate to import functions defined in a source main.rs file. Only library crates expose functions that other crates can call and use. Binary crates are meant to be run on their own. This is one of the reasons Rust projects that provide a binary have a straightforward source main.rs file that calls logic that lives in the source lib.rs file. Using that structure, integration tests can test the library crate by using extern crate to exercise the important functionality. If the important functionality works, the small amount of code in a source main.rs file will work as well, and that small amount of code doesn't need to be tested. Summary. Rust testing features provide a way to specify how code should function to ensure it continues to work as you expect, even as you make changes. Unit tests exercise different parts of the library separately and can test private implementation details. Integration tests check that many parts of the library won't work together correctly, and they use the library's public API to test the code in the same way external code will use it. Even though Rust type system and ownership rules help prevent some kinds of bugs, tests are still important to reduce logic bugs having to do with how your code is expected to behave. Let's combine this knowledge you learned in this chapter and in a previous chapter to work on a project. Right, because chapter 12 is working on a CLI project, so we're going to be getting into some interesting things in the next week. Okay, so I have some general sort of like thoughts on testing and like how to do them, because I've always done test-driven development for the companies that I've worked for projects that I really care about, and it's mainly because I have the philosophy of you can't really sleep at night if you haven't tested your project. And as they said, it's not really for testing things that you don't know about. It's testing for things that you do know about that you either do want to have happen or don't want to have happen. So my current philosophy is we just test the happy paths. Like start with the happy paths. And then anything that you know you don't want to have happen that can happen, write those tests as edge case tests. The other thing is write those tests before writing the functions. So, okay, we're going to make a rectangle. Well, let's make a test that makes sure that a rectangle is created, that it's created with the following key value pairs, and that it can't be too small or too large, or that it will panic when you try to do those. Those might be several different tests we write. Then, as soon as then we can start writing it. As soon as the tests all pass, we're done. Like we don't need to write any more code. And if we do, that means we need to add more tests because we didn't think of everything yet, which is fine. Then we deploy the code. People start using it. they find bugs because people, other developers and users are very good at finding edge cases that we never thought of before, and they report those to us. When we go to fix them, we recreate the problem by writing a test that will fail because it's not doing the thing. It's either doing the thing we don't want it to do, or it's not doing the thing we do want it to do. Then we go in and fix the problem until that test goes away, and then it's this sort of back and forth behavior. But the idea is, because we continue doing that and growing the project in a very natural way, as time goes on, we won't run out, we won't like accidentally re-implement bad behavior again because we have tests for those. Anyways, that's my rant on tests, and sort of how I feel about them and how I use them in real projects that I work on. We'll see how much we can do that in the next project that's coming up next week. But it is about 8 o'clock right now, so it's time for me to get on with my day and go actually do stuff. As you can see, I'm wearing a Hawaiian shirt today because at work we celebrate every Friday is Hawaiian Shirt Friday, so it's a little bit fun. I was worried that the green here would match the green screen, but apparently it's not exactly the right color, so perfect. If you enjoyed this and you want to get notifications when I go live, you can either follow here on Twitch, follow on YouTube for the archive videos, or follow on Twitter for when I tweet out that I'm going live. And other than that, I've got a link to the code. Let's actually put that up there before I forget. Which also means that I need to update where we're at right now, which means we're going to go here, an IO project, build a command line program. Thank you, Miguel. We definitely, last week we had a entire party at work, complete with rum drinks. So, not here. I want to bim the README. Okay, so change, actually I don't need to change that. This is 12. This gets changed here to building this project. That gets put in here. Perfect. I didn't want to actually put that there. I wanted here. There we go. Now, in code, we can now add everything, includes the README. So it's updated where we're at, and we also sort of like played with tests and updated where we are at. We'll push that on up. So that's now going to be live on the GitHub repo where we're at. I'll put this in the chat in case anybody wants to see that, or if anybody's watching the VODs and sort of like sees that there. Otherwise, I have links to this in the descriptions of all the videos wherever they live. And with that, I'm going to take off and go have a happy Hawaiian Friday day, and I'll see you all next week. Monday, 7 a.m. Mountain Time is when we do these things on weekday mornings. With that, have a great rest of your day and have a great weekend.